We're looking at chapter 8.1, solving systems of equations graphically. Thinking back to math 10C, a system of equations is when we look at two or more equations together. We consider them together, so they're connected. The solution to a system of equations is a coordinate point, so an x and y value, that satisfies both of the equations in the system. It's also the intersection point of the graph of both equations. So any point on the graph where the two graphs cross, intersect, touch, etc. First example, using your calculator, find the solution to the system y1 equals x squared, y2 equals x plus 2. Let's go to our graphing calculator and put these in. So if you need more assistance, I'm going to go through this quickly with the graphing calculator, but I did post a video about how to do the basics with your graphing calculator. So if you need more assistance, please go to that video. Also reference the page that I gave you at the beginning of the course that tells you exactly what buttons to push to graph, first of all, to change your windows, to find the x-intercepts, y-intercepts, all of that stuff, okay? So, on my calculator that I have access to on the iPad, it's basically a TI, so I'll be following the TI instructions. So I'm going to enter x squared, hit enter to go to my next one, enter x plus 2. It's essentially the same thing on the Casio, you just go menu, and then choose the graphing option, and then do the same process. After you hit enter, you have the option up here in the top right, actually it's always there, to hit graph. On the Casio, it pops up after you hit the EXE. After you enter your second equation, hit EXE, then you push F6 for graph. So we get this window. If you don't have this window, your window settings are probably different than mine. You can change that by, on a TI, going zoom. This is standard, -10 to +10. So in this case, it's 3. Find whatever option on your calculator says set standard. Push that number. On the Casio, you push F3 for window, and then F3 again for standard. Okay, so we all have this screen. We want to draw a sketch of this graph and find the intersection points. So let's draw a sketch of the graph. The first one is y equals x squared. All we have to do to plot some points is pick some x values, square them, and that gives us our y value. Starting with 0. 0 squared is 0. So the point 0, 0 is on this y equals x squared graph. For 1, if x is 1, y is 1 squared is 1. If x is -1, -1 squared is +1. If x is +2, 2 squared is 4, so y is 4. If x is -2, -2 squared is +4. And if x is 3, y is 3 squared is 9. And if x is -3, -3 squared is +9. I can connect these points to make my quadratic. Not very pretty, but that's okay. There's my graph y equals x squared. Next one, y equals x plus 2. Well, if we think back to math 10C, this is mx plus b form. Y equals mx plus b. That's a linear equation. M is our slope, and b is our y-intercept. So, y-intercept of 2, a slope, there is no number in front of x, so that means it's a 1. Our slope is 1. Y-intercept at 2, I'm going to change my color. Y-intercept at 2, slope is +1. So as we move to the right, we are going up 1. and over 1. So up 1, right 1, put a dot, up 1, right 1, put a dot, up 1, right 1. If you want to go down, you go down and left. So down 1, left 1, down 1, left 1, down 1, left 1, etc. I can join those points with a line. And there we have y equals x plus 2. So we've got our two graphs sketched. We want to find the intersection points. On the TI, second trace always to find information. On the Casio, F5. We want intersection, that's number 5, and on the Casio it's also F5. So hit number 5. On the Casio it's just going to tell you the answer. You use the left-right button to switch between the two answers. On the TI, we do it a little different. It says first curve, and it has a little dot. Yours is usually a blinking cursor on one of the graphs. So you just hit enter. It jumps to the next graph. You hit enter again. It says, do you want to guess? You hit enter again, and it tells you that point. So it gives us the left intersection point, which is at -1, 1. Right there at -1, 1. We want to repeat this process. On the TIs, we have to do the whole thing again. Second trace, number 5. This time, before you hit enter, move your little dot closer to the intersection point you're trying to find. Hit enter, do the same thing. It jumps to the next graph. Move your little dot closer to the point you're trying to find. Hit enter. Do you want to guess? No. Hit enter again, and it tells me that it's at 2, 4. There's our graph. We've got our little sketch. So what did we do? Let's write down a little note here. We graphed and find intersection points. That's what we do on our calculator to solve the system. Our solutions that we got were -1, 1 and 2, 4. Let's just do a quick verification of these points. How do we do that? We sub in each point to each equation and check that the left side equals the right side. We'll start with the point -1, 1. We take our first equation, y equals x squared. We plug in our values. Y is 1, x is -1. -1 squared. It's important if you have a negative number squared, you put it in brackets and then the squared outside. -1 times -1 is +1, so we get 1 equals 1. Yes, that works. Do the same thing with this point for the second equation. Y equals x plus 2. Y is 1. X is -1. -1 plus 2 is +1, so we have 1 equals 1. So that works out. Next solution point is 2, 4. Starting with y equals x squared. Subbing in, y is 4, x is 2. 2 squared is 4. We get 4 equals 4, which is true. Last point in the last equation, y equals x plus 2. Y is 4, x is 2. 2 plus 2 is 4. We get 4 equals 4. There we go. We have verified that those solutions are correct by showing algebraically that they satisfy each of the equations in the system. I'm going to get rid of this. Number of solutions. How many possible points of intersection can there be between a line and a parabola? Well, we saw the example we just did where we had two solutions. So in that case, we'll typically, we will have a parabola that either opens up or down, and then we have a line that crosses through the parabola, and we get 1, 2 points of intersection. We could also have 1 point of intersection. A parabola could open up or down. And then our line, if it's tangent to the parabola, then it kind of glides along the edge of the parabola and intersects at 1 point, but it doesn't actually cross anywhere. So hard to see, but let's say that that's the point that it actually touches the parabola. Everywhere else, it's on the bottom right side. It's not actually touching the parabola. So that's one solution, and we could also have 0 solutions. Here's an example of what that might look like. Your parabola could open up or down, doesn't matter. And then you've got a line that does not touch the parabola in any way. That is our options for number of solutions if we have a parabola and a line in our system. Next, how many possible points of intersection can there be between two parabolas? We no longer have a linear in our system. We're now talking about two parabolas. First possible scenario, we could have 0 solutions. We've got two parabolas, one that opens up, one that opens down, and they just never intersect. They don't touch each other at all. Next option, and there's 2 of these, we could have one, and it looks 2 different ways that it can look. So we could have one where one parabola is opening up, one parabola is opening down, and they actually intersect. They just touch at the vertex of each parabola. Or we could also have, let me get a grid here. We could have where we've got both the parabolas opening the same direction. And they're essentially the same parabola. One's just shifted to the side. So then we have where they intersect at one location. And they're not the, if we continued this line and this line, they would just continue to be parallel to each other. Okay, they would have to be that so that they don't intersect again. So, and same with this line and this line. They would just have to continue parallel. So the two parabolas would have to be essentially the same shape, the same width. They're just, one is shifted off to the side, and then we could have one solution. Another option is to have 2 solutions. This is the one we see most often, and there's also 2 ways that we can see this, but the first one is the one we see the most often. Let me just erase that because it was ugly. Okay, and I'm gonna draw a grid here. First way that we see, which is most of the time what we'll see with these 2 parabola systems, we have a parabola that opens up and a parabola that opens down. So they cross each other twice. We have 2 intersection points, 2 solutions to the system. The other option is similar to the second possibility for 1. It's just that they're not the same width. So if we had like a slim parabola, and then if we had a much wider parabola, we see that they cross 2 times. Okay, so 2 different ways that we could have 2 solutions. And then our last possibility is to have an infinite number of solutions. You can use the infinite symbol, sideways looking 8 thing. And what this looks like is the parabolas are actually on top of each other. So the equations in the parabolas might look different, but when you actually graph them, they are exactly the same. So you get the parabolas just overlap each other, which means that they're always touching, and anywhere that the 2 parabolas touch is a solution to the system. So there would be an infinite number of solutions because there's an infinite number of places where the parabolas are touching. Solve the following system of equations graphically and verify your solution. X squared minus 6x plus y plus 3 equals 0, and x minus y plus 1 equals 0. We need to put these into y equals form so that we can put them in our graphing calculator. In this case, in the first example, the y is positive, so we want to leave it on that side and move everything else away. What do we end up with? We have y equals, we're going to have to subtract x squared, then we're going to have to add 6x, and then we're going to have to subtract 3. Second equation, x minus y plus 1 equals 0. Since the y is negative here, we want to move the y to the other side and leave everything else. What do we get when we do that? The y becomes positive because we're adding y, equals, everything else stays as it was because it didn't move, x plus 1. We're going to graph those in our graphing calculators. Let's see if I can bring that back up. I know there's a way to do it, but I'm not very tech savvy. I guess I can leave that big. Alright. Going to y equals, I want to get rid of the old stuff I had. Clear, enter, nope, not enter, down, clear, enter, sorry, turns on and off the equation so you won't see it on your graph. Alrighty, I'm going to enter this here, negative x squared. If you're entering a negative versus a minus, negative is the bottom button that's right to the left of enter that's in brackets. So that's the negative x squared. If you use the minus button there, you will get an error when you try to graph. So make sure you use the little negative that's left of the enter. Then plus 6x, then minus 3. So that's the regular minus. Now we can hit enter to go to the next one. And then x plus 1. Want to graph it? There's our graph. We don't need to change our windows. We can see everything. We want to find our solutions, our intersection points. Second trace, number 5. First curve, yes, we're on the first curve. Hit enter. Jumps to the next one. Second curve, yes. Hit enter. Guess, no. Hit enter. Tells us the point. So 1 and 2. So I can plot that. Positive 1, positive 2. Want to repeat that to get the second one. Second trace, number 5. Remember to move your little dot closer to the intersection point you're trying to find on the second round. First round it doesn't matter, it'll just give you whichever one it's closest to. Second round you need to move it closer. Same with on the next graph. Move it closer. I really wish I had a Casio graphing calculator app that would pop up on the iPad so that I could use that, because it's just so much easier. Hit enter again. And the intersection is 4 and 5. So x equals 4, y equals 5. Put a dot. Okay, shrink this guy. Let's graph these two equations. So let's do the linear first. It was y equals x plus 1. Remember, that is a 1 there if there's nothing in front. So mx plus b, our slope is 1 and our y-intercept is 1. If I put a dot at y-intercept of 1, our slope is positive 1. So it's moving up and to the right or down and to the left. So as I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. If I want to go down, down 1, left 1, down 1, left 1, down 1, left 1. Okay? Then I can join those points with a line. And that is our y equals x plus 1. Second one is much more complex than just x squared, so I can just use my graphing calculator to find some points. I already know that it's going through the intersection points, which were there and there, so I know it's going to go through those. Another point, I need like 3 points to graph a quadratic really nicely. You want the vertex and then at least 1 point on either side of the vertex. So let's find the vertex. Second trace, it's opening down, so it has a maximum point, like a mountain or a hill. Number 4, I have to go left bound, right bound, right? So I'm looking at the blue line, I'm looking at the quadratic. I'm going to put my little dot somewhere left of the maximum point, maximum value. So it's left of that. I hit enter. Now it tells me to go right, so I move my little dot until it's somewhere that is definitely right of that maximum point. Hit enter again, and usually it'll ask me to guess, but that's okay. On yours, it should do that. Just hit enter a third time. So 2.995 and 5.99 blah blah blah. So 3 and 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. There we go. So I can give a quick sketch. Not the best, but not bad either. Alright, that is our y equals negative x squared plus 6x minus 3. I believe that was our equation. Negative x squared plus 6x minus 3. Good. Then it wants us to verify our solution. So first of all, let's write down what our solutions were. We can write them on the graph. They were 1, 2, and 4, 5. We can also write them over here. One, 2, and 4, 5. Now let's verify. I'm going to start with the point 1, 2, and plug it into my equations. Starting with, I'll start with the first one, y equals negative x squared plus 6x minus 3. I don't really need this. I can get rid of this for the moment. Make this bigger. Okay, let's sub in our information. Y is 2 equals negative bracket 1 squared. Notice how the negative was already in there. It's a negative in front of x squared. It's not a negative x and then squared. So the negative's in front of the brackets. Plus 6 times x, which is 1 minus 3. 2 equals 1 squared is 1, so we have negative 1. Plus 6 times 1 is 6 minus 3. 2 equals 6. Take away 3, take away 1. Let's take away 4 is 2. 2 equals 2. It's true. True story. Next equation, y equals x plus 1. Sub in our information. 2 equals 1 plus 1. 2 equals 2. True. That's our first point verified. Let's verify the point 4, 5. Starting with the first equation again, y equals negative x squared plus 6x minus 3. Subbing in our information, y is 5, negative bracket 4 squared plus 6 times 4 minus 3. 5 equals negative. Feel free to use your calculator for all of this, even like 1 times 2, like doesn't matter, just don't make mistakes. So 4 squared is 16, so we get negative 16. 6 times 4 is 24, plus 24 minus 3. 5 equals, I'm going to use my calculator just to double check, negative 16 plus 24 minus 3. Yep, we get 5. 5 equals 5. Last one, y equals x plus 1. Y is 5, x is 4. So we have 5 equals 4 plus 1. 5 equals 5. Yes, that's true. There we go. We've solved. We did a little sketch of our graph. We verified algebraically. Next example. Solve the following system of equations graphically. Verify your solution. So exactly the same as we did above, just another practice. Again, we need to make sure it's in y equals form. In this case, we have a negative y on this side and a negative 35 on this side. We basically need to switch those around to the opposite sides. So we have to add y to both sides and add 35 to both sides. We end up with y equals 2x squared minus 16x plus 35. Next equation, same thing. We have a negative y and a negative 11. We need to add y to both sides, add 11 to both sides. We get y equals 2x squared minus 8x plus 11. Let's graph in our graphing calculators. Go back to my y equals, clear that, enter the first one, 2x squared minus 16x plus 35, enter second equation, 2x squared minus 8x plus 11, graph, and there's our little picture. We can see an intersection point. It looks like the two equations. I'm just going to change my window. I want to focus more on the positive x, positive y, because that's where my graph is. So if I go down to my x max, I can change that to, let's say, 20. If I go down to my y max, I could change that also to, let's try 20. And then graph. So it just gives me a better image. It definitely, to me, looks like they're only going to intersect at one point. So this is that example where they're the same width, same shape. One is just shifted over from the other. So they just have one intersection point. let's give a quick sketch. When we have a quadratic in standard form, the constant term represents the y-intercept. So we know that our y-intercepts for these graphs are at 35 and 11, which is a little bit higher than what our grid shows. We only have a 10 by 10. So we might not have a great image of these two graphs, but we can plot the intersection point, and we can also find the vertex to help us to graph. So let's find the intersection point first. Second trace, number 5. First curve, hit enter. Second curve, hit enter. Do we want to guess? No. Hit enter. It tells us our intersection point is 3, 5. X equals 3, y equals 5. Put our dot. Okay, let's find the vertex for the red graph first. So second trace, as per usual. They're opening down, so we have a minimum, number 3. It wants us to be left bound, so I'm looking at the red graph. Left of the vertex would be this side of the graph. Hit enter. Then I need to go right bound. Using my cursor, I need to move to the right side of the red graph. Hit enter, and it tells me the minimum is at x equals 2, y equals 3. And because I know that it also goes through the point that is the intersection point, which is 1 to the right and 2 up, because quadratics are symmetrical about the vertex, it would also have to have a point that is 1 to the left and 2 up. So there's my 3 points that I can use to help me draw this quadratic. Here we go. I want to do the same for the second graph. Second trace, number 3, it's a minimum. Now we want to find the find it for the blue one. So I think for you might have to like use your up down arrow. I think it usually says like the equation in the top left of which one you're trying to do. So just try using your arrows to get your little dot to be on this graph, the second one that we haven't done yet. And then when you're left of the minimum point, so you can see my dot is left of the minimum point of the blue graph, hit enter. Then we need to go right bound. Okay, I am right of that minimum point on the blue graph, hit enter, and it tells me it is at 4 and 3. So I'm going to, first of all, change my color. 4, 3. I also know it goes through that intersection point at 3, 5, which is 1 to the left and 2 up from the vertex. So symmetrically, it would have to also have a point 1 to the right and 2 up from the vertex. I can use those 2 points to help me draw my quadratic. And there we go. Okay, our solution point was, what was it? 3, 5. That was our solution point. Three, 5. Now we need to verify. Let's start with the first equation. Y equals 2x squared minus 16x plus 35. Sub in our values for x and y. Y is 5. X is 3. 2 times 3 squared minus 16 times 3 plus 35. I'm going to use my calculator. Once you have it to this point where you've written out all the values, you can just plop it into your calculator. That's this step here, that's showing me enough algebraic work. And then if you just show me 5 equals 5, that would be fine. I'm going to change these so they actually look like 5s. A little better. Okay, so I'm putting in 2. Let me go back to my exit. Where is, there we go. Not used to working with TIs. Okay, plug it in. So 2 bracket 3 bracket squared minus 16 times 3 plus 35, enter, and it gives me 5. 5 equals 5, true. Next equation, y equals 2x squared minus 8x plus 11. Subbing in our values for x and y, 5 equals 2 times 3 squared minus 8 times 3 plus 11. Typing in the right side, I can do it a little different. I can do 2 times 3 squared. I don't actually need those brackets, but if it was a negative x value, then I would need those brackets. So it might be a good habit to just continue doing them. 8 times 3 and then plus 11, enter, and we get 5. 5 equals 5. So we verified our solution. We sketched a graph, we found the solution using our graphing calculator, and then we verified our solution algebraically. That's it for 8.1.